Assalamualaikum, greetings. My name is Muhammad Rifqi, and I am from Clashawa in the Data Transmission and Network Department, which is DKR. Today, I will be sharing a brief overview of my project. I would like to express my gratitude to my lecturer, Sincere Dr. Muhammad Firdaus, for his invaluable guidance and support in bringing this project to fruition. Thank you.
Okay, so Assalamualaikum and hi. My name is Amar. I'm the leader of this group project.
Hi, Assalamualaikum. I'm going to be introducing myself. My name is Muhammad Ruzainn bin Muhammad Razif. I'm in Clashawa. I'm 19 years old and currently right now in this MJI. I'm on the second semester. Okay. Okay, I'll be explaining the objectives now. There will be 5 parts. The first one is design, second one is develop, third is to simulate, fourth is the feedback, the fifth is to verify. Okay, the first objective is to design a color memory game using an Arduino Mega 2560. This includes setting up the hardware with LEDs for color display, like buttons for user input, and a buzzer for feedback. The design needs to allow players to easily see the color sequence and respond using the buttons. Okay, for the second one is to develop. Next, we develop the code using Arduino IDE to control the game logic. This involves creating a sequence of colors that players will need to memorize, handling inputs from the buttons, and managing the LEDs to display colors that's in a way that's challenging and fun. For the third one is to simulate. So basically the circuit and its test its functionality in Produce 8. By using Produce, I can verify the circuit and code work correctly before testing on the actual hardware, saving time and helping to troubleshoot potential issues early. Okay, next but not least, the feedback. So our user feedback is more like an interactive experience. With this objective, the game provides immediate feedback using LEDs and buzzer sounds, indicating if the player's input is correct or incorrect. This helps guide players during the game and makes it more engaging. Okay, the fifth one is to verify, the last one. To verify the timing accuracy and response speed in game. This means checking the time between color displays is suitable for players and that the game responds quickly to button presses, ensuring smooth and responsive gameplay. Production. The project involves creating a color memory game using the Arduino Mega 2560 or 2560 or 2560. It generates a sequence of colors which the player must remember and repeat. It's like a memory game where the Arduino constantly makes the level harder and keeps testing your memory, which if you have a fish kind of brain or something.
It starts by discussing the software and components used in this project. First, we will look at the software and then go through the key components that make up the color memory game. For this project, the primary software we used was the Arduino IDE. The Arduino IDE is essential for writing, compiling, and uploading the code onto the Arduino Mega 2560. We use it to create the logic for the color memory game, manage inputs from the push buttons, control the LED sequences, and trigger the buzzer sounds. Without this IDE, we could not be able to interact with the hardware. In addition, to the Arduino IDE, we also use Proteus 8 Professional for simulation purpose. Proteus is a simulation software that allows us to test our circuits designs virtually before physical implementation. This helps us save time and troubleshoot potential problems in the design and coding stage. Using Proteus ensure that the game functions properly on the hardware when we test it physically. Now, let's dive deeper into the Arduino IDE. The Arduino IDE is the platform where we write our code. It's simple and user-friendly, which makes it ideal for creating small projects like this. In the case of our color memory game, the code we write in the Arduino IDE controls the core functions of the game. It generates the random color sequences, checks the user input to validate whether they match the sequence, manage the timing of each sequence, also controls the LED and buzzer for feedbacks. Once we write and verify the code in the Arduino IDE, we compile it and upload it to the Arduino Mega 2560 via USB. The code then starts running on the Arduino and controls the physical components connect to it such as the LEDs, buttons and the buzzer. Moving on to Proteus 8 Professional. This software plays a crucial role in our project development. Proteus allows us to simulate and test our circuits before connecting the physical hardware. This saves a lot of time and allows us to verify that everything works as expected. For the color memory game, Proteus let us simulate the LED sequence, button press and buzzer feedback. It also helps to check the functionality of the game logic, ensuring that the sequence is generated correctly, the buttons respond accurately and the buzzer gives the right feedback when an error occurs. Using Proteus, we can test the code and see if the components respond correctly in a virtual environment, which significantly reduces the likelihood of hardware issue during physical testing. Let's talk about the key components that make the color memory game interactive. The first and most obvious are the LED, red, green, blue, and yellow. These LEDs are used to visually display the color sequences that the player has to memorize. Each LED represents a different color in the game sequence, and the player must press the corresponding button in the some order the LED light up. The color sequence generated by the system is random, so every round is a different challenge for the player. The LEDs are connected to the Arduino Mega 2560 and we control them via the digital pins. We can turn each LED on and off, creating the flashing sequence which makes the game both visual and engaging. Next, we have the push buttons. The push buttons are essential for user input. They allow the player to interact with the games by selecting a color that matches the sequence displayed by the LED. Each button corresponds to one of the four LEDs: red, green, blue, and yellow. When a player presses a button, the system checks whether the selected color matches the current color in the sequence. If it does, the game continues, and if it doesn't, the player is alerted with a buzzer sound, and the game either ends or restarts, depending on the game's design. Push buttons are a great choice for input in this kind of game because they are simple and effective, allowing players to focus on the game without distraction. Finally, we have the buzzer. The buzzer adds an important layer of interaction by providing audio feedback to the player. When the player makes a correct selection, a short beep is played, indicating they are on the right track. However, if they make a mistake, the buzzer produces a longer or different sound to alert them of the error. This auditory feedback is essential because it helps reinforce the memory aspect of the game. It keeps the player engaged and lets them know if their input was correct or not, which adds to the overall experience of the game. The buzzer is also connected to the Arduino Mega 2560 and is controlled by the same logic that manages the LED and buttons, ensuring that the sound effects correspondent with the game's progress and user interaction.
So I'm going to dive into the schematic diagram, the simulation and the results of our project. So I'm also going to show you a little bit of the videos that I found online, the reference. So let's just jump right into it. Presentation for my part. The schematic diagram. So the schematic diagrams shows how each component is connected to Arduino Mega 2560. We created this diagram in Proteus 8 to visualize the setup and ensure all connections are correct. So we have right here the LED buttons. We use 4 LEDs, each representing a different color. And it's connected to specific pins on, as you can see here. We use connecting pins because the wire makes it look a little bit messy, not really neat. So each LED has a corresponding button, allowing the player to input the sequence. The buttons are connected as inputs with pull-up resistors or to stabilize the signals or to prevent errors. So this is the push-up buttons that we use to play the game. So we also have the buzzer. It's connected to another digital pin on the Arduino. It provides audio feedback, playing specific tones for each color in the sequence and a unique error tone if the player presses the wrong button. So this schematic diagram allow us to clearly define each connection and help guide us when building the actual circuit on a breadboard. So later I will show you the simulation of our project. So right now, let's just dive into the flowchart. So first, the start, we use the setup. It initialize the LED button and buzzer pins. Set the random generator and set the first sequence step. The second one is this is the loop part where it plays the sequence. It shows the current sequence using the LED and buzzer. And the user presses button to repeat sequence. So where also we need to check the user input. If correct, add a new step to the sequence. If incorrect, the buzzer has a timeout. It resets the game and generate a new sequence. So it might not be really detailed. So I'm going to break down the code by this flowchart. Here, we define the pin numbers for each LED button and the buzzer by assigning each component to a specific pin. So it's easier to control them later in the code. For example, a red LED is connected to pin 2 and green button to pin 7 and so on. So uh, right here, we define a tone frequency for each color. The tones will always play when each corresponding LED lights up. This frequency is in hertz, determines the pitch of each sound. So the tone function later will use this value to create unique sounds for each LED. So right here, these are variables essential to the game logic. Sequence 100 is an array that stores up to 100 steps of color sequence. So there are 100, for example, there are 100 levels you can play. So the sequence length keeps track of how many steps you include in the sequence, and user step is used to keep track of the player's progress attempt to play the sequence. So right here, these are function prototypes. Declaring these functions here allow us to organize code more clearly. We'll define these functions detail later in the code. So right here, the function that initialize the hardware and variables. The pin mode sets the LED and buzzer pins as an output, while buttons are set as an input with internal pull-up resistors to stabilize the signals. Random seeds are the random number generator using floating analog. Inputs provide a pseudo random seed. Sequence generates first step in the game sequence by choosing a random number between 0 and 3, which represents the LED. So right here, it will play randomly first, then the sequence will add up later. So there's the loop function. The loop function The loop function contains the main game logic. So when the play sequence is run, it displays the current sequence by lighting up LEDs and plain tones. For loop iterates, it irritates through the sequence, checking its user input against stored sequence. So what does it mean by that? Because the sequence is randomly, right? So when each sequence is played, you need to be in order so that you get the correct answer. Get user choice, get user choice. Get user choice here. Waits for the player to press a button. If the user input doesn't match the current sequence step, or if there's no input, the game plays an error sound and resets. So for the flowchart, if you notice, we don't have end for this flowchart because it keeps playing on repeat whether you restart or you add more sequence. Reset or add more sequence. Add new step to the sequence. So you can play this game repeatedly. So that's the play sequence function. It plays and back the start sequence for the player. We also have delay here so that the color doesn't once went so fast, the sequence doesn't play so fast. And we have the activate color function. This turns on the LED and plays the stone for a specific duration, creating light and sound feedback so that the player can identify which LED to press. And there's the get user choice function. Get user choice wait for player to press a button and returns a value based on which button was pressed. If statement check the button read as low. Each if statement checks if a button is pressed read as low. Then a delay 50 is used for debouncing and ensuring that one button press is not registered multiple times. Once a button is pressed or released, it returns a unit number corresponding for each button 0 for red or 1 for green or etc. It's randomly sequenced. So there's a reset game function. So when reset game, it resets the game if the player makes a mistake. So the sequence length and the user step are reset to a new game. Sequence is back to 0 is reinitialized with a new random first step. So and delay will be 1000. It provides a short break for before restarting, giving the player time to prepare for the next round. So this code creates an interactive LED memory where the player must repeat an increasing sequence of LED sound with error handling and game reset features. So this is our result. This is how it looks like physically, and I will show you the video. Okay, so right now I'm going to show you the simulation of our project. So as I told you earlier, this is our schematic diagram. We use Arduino Mega 2560, button, LED blue, green, red, yellow, and the sounder. This is the buzzer, the buttons, and the sounder here. So to start the simulation, we just press play. So that is the first sequence. So for example, I press the correct button. Then you add up to another sequence. So we need to memorize the color properly so that the game will continue and add up more sequence. So for example, I do wrong. I do the wrong sequence. So the first sequence is yellow, right? So for example, if I press blue, then it will sound the reset. Then it will reset the game. So the game starts over randomly. So the new game starts with LED red. Then it goes on with the new random sequence. It add up back. So I think that's basically all for our simulation. So in conclusion, this Arduino LED memory game was a rewarding project that combined coding, circuit designing, and problem solving through the schematic design, simulation, and testing. We are able to create a fully functional game that challenged memory and attention. So the process of designing, simulating, and assembling the project provided valuable insights into how we can leverage the Arduino technology. So let me pass to Zain for the next slide.
Now it's time for the results. The simulation for the color memory game was successfully completed in Proteus 8 using the Arduino Mega 2560. The system accurately generated random color sequence, which were displayed on the LEDs, and the buzzer provided appropriate feedback for the correct and incorrect user inputs. The sequence and timing for the game worked as intended, with the system responding correctly to user interaction. The Proteus simulation effectively verified the functionality of the Arduino Mega 2560, confirming that all the components, including the LEDs, buttons, and buzzer, were correctly integrated, and the game's logic gives the sound. So basically, after running it and confirmed that the game's functionality with the LEDs displayed the sequences with the buzzer providing feedback. All objectives were met within the simulation environment. So basically, our project was successfully made in Proteus 8, and there were all like flowing straight. They were all running smoothly, and at the same time, everything was done in a perfect timing. In conclusion, the project successfully achieved the goal of developing a color memory game using the Arduino Mega. The Proteus 8 simulation validated the proper operation of the LED. Button inputs, buzzer feedback, and confirming that the game logic and interaction functioned as expected. All objectives were met, including the generation of random color sequences, user input validation, and providing immediate feedback. The project demonstrated the effectiveness of the Arduino Mega 2560 in handling interactive memory games and highlighted the value of Proteus for testing the refining circuits design before physical implementation. Okay, so it basically is like the project goal achievement. So what I'm gonna say is that the project is a huge success, and the simulation is basically that all of it was the help from Proteus 8. Thank you for that. Thanks. Special shout out to that Proteus. And not to mention that the random color sequence added complexity. So like it makes the game more harder by time from time. Let's say from the first start, let's say from the. Also thanks to my Sensei Firdaus for providing me this assignment, and for me to keep on explaining and sharing with everyone about our project.